Hello everyone. Am I audible? Hello, am I audible? Can anyone confirm?
Order.
Okay. So we'll wait for 5 minutes and then we can start. Okay.
आप इसके अंदर ले लीजिए पहले आप बात कर लीजिए फिर आप बता दीजिए ओके
ఇప్పటికైనా తెచ్చుకో మమ్మీ ఇంకెప్పుడు
Okay, so I think we can start now. So hello everyone.
Good
Good evening.
evening, sir.
Good evening, sir.
Yes, good evening. So today we are going to discuss week 11 practice assignment. So we already discussed the concept in the previous few sessions. So today we'll discuss week 11. And in
Sir,
week
it's
12,
already discussed, sir.
week 11 also discuss practice assignment question.
Yes, sir.
Okay, great. Then you have any other doubt from week 11 or any of
Sir,
the week?
from week 10.4 lecture has to be revised, sir. That pseudocodes have to be explained, sir. 10.4, lecture
10.4.
number
Okay,
10.4.
just a minute.
Yes.
Pseudocode for each label graph, right?
Yes, sir.
Okay. Okay, so let me share my screen. So we are in the last week, and week 12 is just some few tutorials are there, no assignments are there. So we have enough time for end term preparation, right? So end term is on 22nd, so still we have good amount of time.
Excuse me, sir.
Yes,
Sir, what is the syllabus for enter?
all 12, 11 weeks, 12 weeks, you can say.
Equally weightage all week.
Weightage is not decided, but there will be 20 questions and 20 questions, and out of 20 questions, you can expect around 6 to 7 questions from week 8 to 11. Okay, like this. The remaining questions will be from rest of the week.
Okay, sir. Thank you.
Please mute. Okay, so let's discuss this pseudocode thing 10.4, right? Yeah. So which pseudocode? This one.
All of them, sir. Like 10.3 is done, 10.4 is left over.
So here we have a trains data set. So we have already discussed this card. This is a train number, distance travel, station name, arrival, and departure. So day one means what? On this particular first day, started from Kolkata and then into Dhanbad, Varanasi, Kanpur, like this, right? So Kolkata is the starting station, Bikaner is the ending station for this particular train number. And this is the arrival and departure time and total number of distance in kilometers. This information is given to us, and if you observe here, so this is Monday, Wednesday, Thursday, Saturday, Sunday, Thursday and Sunday. So these on these 4 days, this train is running. Okay. Similarly, this is the train data set card and this is a station card. Okay. Station means what? Here you can see a station name Nagpur, and for this particular station Nagpur, which are the train that going and coming through this particular station. So train number along with the arrival and departure timing is present here, and the days through on which this particular trains are running. This is about the trains data set. We have information about the train and the station here. Okay. So here you can see this two card. Then each train is out of the station. Each route station is a route place of station passing through. Yeah, this is what we have discussed. Now we want to compute pairs of station connected by a direct train. So this is what we want to find out, pairs of a station connected by a direct train. Now represent start and end station of trains in the nested dictionary. So when we can say there's a direct train between two stations, when particular train is starting and ending, so we can say that the train is going through those two stations, right? Direct train between those two stations. So we can represent this in terms of nested dictionary. So here we can see trains T, then start. So if I say trains is basically a dictionary, and inside that we have this nested dictionary. And T is what? Train number here. So for that particular train number, we have a start timing and end. So we have a start corresponding value, and then we have end corresponding value. Okay. So this is about the train dictionary, nested dictionary. For each train number, so inside this main dictionary, trains dictionary, we have a train number as our inner key, and the corresponding value is a dictionary which is having start and end timing here, right? So this is about the train dictionary. Anyone any doubt in this particular slide?
Sir, here key would be T. I think T, na?
Sorry,
Train. Key would
T
be
will
T.
be, yeah, here T is train number, this 12259, and start and end is basically value here.
That would be key of the this dictionary trains.
Start and end is the basic key of this dictionary T, train number. Then we have
Okay.
again one more train, let's say for example T2, and then we have again one more corresponding dictionary like this. Okay. So nested dictionary. So inside that, when I say keys of train, so when I say keys of train. So tell me what will be the answer for this keys of train?
The list of all the
T1 and T2.
train
Yeah.
numbers.
So list
List
of
of all
train
the train
numbers.
number.
Yeah, list of all the train number like 12259, 12260 like this. And here T1, comma T2 till number of train number. Okay. So this is about the trains dictionary. Now, station A and B such that train starts at A and ends at B. Okay. So we can say a direct train when the train start from A and ends at B. So here you can see a procedure here, procedure direct routes. So we are taking train as an input here, that entire dictionary as an input. Here we have a station that is basically empty dictionary. Then what we are doing in this for loop for each T in keys of train. So we already discussed what is keys of train, list of the train number. So here for each T in keys of train. So for every T that is basically a train number, we are doing this particular thing. Now what we are doing here, station. Station is what? Currently empty dictionary. In that empty dictionary, what we are doing? Trains T start and then we are putting this as value. Okay. So here you can see station. The corresponding key is what here? Yes. What do you understand by this particular line here? Anyone?
Sir,
Let's.
starting
In
station of
dictionary
train T.
station,
Hmm.
in dictionary station, there is a dictionary trains and T is considered as key for a start station.
Yeah. So train is a dictionary, T is the key, and corresponding start is what? The station here, right? So here you can see start and end value, corresponding value. So that is true here, right? So what we are doing inside this for loop, station is initially empty. Okay, so empty dictionary like this. Now here if you observe, this entire thing is a key here for this particular dictionary, right? And what will be the key? The value of that particular thing, station T and start. So what is that value here? That station name, right? Whatever the value of this corresponding start, that will be present here. Now let's say we have one train. Let's take one station here. Train number. Okay, trains data set 12259. Then we have start Kolkata, Bikaner. Kolkata. Then we have end Bikaner. Okay, this is for only one station as of now, one train as of now. So what we are doing here, trains. So we have gone to a trains dictionary. Then we are going to that particular train number inside this train. So we have gone to that particular train number, and then we are going to this start key here. And inside this particular train, we are going to this start. What is the corresponding value? That is Kolkata. So in this station, we are putting Kolkata equals to true. And similarly, again, end station is what? Bikaner. So Bikaner equals to true. Okay. So we are doing this and we are repeating for all the train number here, right? Each for each team keys of train like this. So for every train, we are storing what we are storing inside this station, Kolkata, Bikaner, all the station name along with whether the train is running or not, right? True or true. That's it. So this is about this what for loop is doing here, right? So create a matrix, so record direct routes, compile a list of station from our trains, right? So this is what we are doing here. And in this way, what we are going to get here in the station, every station name and then simply true. The corresponding value will be true. So if I talk about what is keys of station, what will be the keys of station? Yes. So this is just for
Sir,
one train.
list of all the stations which are terminal for any train.
Yeah. So if I talk about 12260, starting station is say Mumbai and ending station is say Delhi. Okay. Now if I again go for this particular for loop, here we will add Mumbai equals to true and Delhi is also equals to true. So if I just consider these two trains, the keys of station will be what? List of a station. Kolkata, Bikaner, Mumbai, Delhi. And this is the either starting station or ending station, right?
Yes, sir.
Yeah. So this will give me list of a station, list of stations of a train that is basically either starting or ending station. So you can consider this particular thing. Now, what is length? Length will give me number of element in this list. So number of stations here, right? Present in this particular list. So that is will be a length.
I think though might be Kolkata and Bikaner must be under a different list, and Mumbai and Delhi should be under a different list. And they should be demarcated within the dictionary.
No, no. If we consider these two trains only here, so inside the trains dictionary. So what we are doing here, for every train number, we are doing this particular thing. Okay. So for first train 12259, so train T corresponding is 12259. Then we will go to start. Start is Kolkata. Then this is the key, and this corresponding value is true. So we have added start Kolkata here. Sorry, Kolkata equals to true here. Then here what we are doing, we are ending station here, right? The ending station is what? Again, that particular name Bikaner and set equals to true. Then we are going for next for loop. The next for loop, we have a next station that is, sorry, next train number. Let's say 12260 here. And again, we are doing the same thing here. What is the starting station? What is the ending station? So starting is Mumbai. So again, we are adding into that same dictionary in the same way. Mumbai true, Delhi true, like this. Okay. So here what we are doing, we are simply adding the starting and ending station in the stations dictionary. Okay. And this is up to this particular for loop. Now here what we are doing, we are finding out the list of a station here. And what is length? Number of a station in that inside that particular list. Okay. And then we are creating a matrix n by n. So that will be n by n matrix here. Okay. Now what we are doing, so station index equals to empty dictionary I equals to 0 for each as in keys of station. Okay. Now what is keys of station? Again the station number Kolkata, Bikaner, Mumbai, Delhi like this. Now for
List of
every
stations.
list of a station Kolkata, Bikaner, Mumbai, Delhi. Now for every station in this particular list, what we are doing, station index and that corresponding S. So S is what? A station name equals to I. So initially I is equals to 0 and then we are incrementing I equals to 1. So output of this particular for loop is what? Like this. So it will be a station index. So here first is Kolkata. So Kolkata, then the corresponding value will be 0. Then we have Bikaner, corresponding value will be 1. Then we have Mumbai, corresponding value will be 2. Then we have, sorry, 2, yes, Delhi, corresponding value will be 3 like this, okay. So what we are doing here, we are assigning the index value to that particular station of this dictionary, stations dictionary here, right? So station index for the first station, it is 0. Then we are incrementing value of I to 1. Go for next station. Next station is Bikaner here. Then we are going to add the Bikaner corresponding value is I, that is 1. Again increment, that is 2 here. Again, we are doing the same thing here inside this particular for loop. So we are allocating the index number to every station here. Okay. So Kolkata 0, Bikaner 1, Mumbai 2, Delhi 3, like this. Okay. Any doubt up till now what we have discussed? Till this for loop now? This and this?
Sir, if we
Huh?
not allow giving value of a station index, so what would be effect on this pseudocode if we not give value to a station index?
Here, if we are not giving the value to corresponding station number, right?
Right, right.
Yeah, we'll discuss this after. Once we complete, we'll get to know. Okay. So as of now, what we are doing this, we are allocating the index to this particular station. Okay. Now what we are doing in this particular for loop. So for each T in keys of train, again a train number here, keys of train. So you can see keys of train is what? Train number like this. Now I is what? I is basically station index. Now this is what is the output of this train T. So for this particular train, starting station is Kolkata, right? So station index Kolkata, output of this will be 0. Station index trains T n for this station, n is Bikaner is equals to 1. Okay, did you understand what I have done here? How we got 0 and 1 for I and j?
No, sir.
Okay. Okay, you understand this how station index dictionary came?
Yes, sir.
So what we are doing here after this, for each T in keys of train. What is keys of train? Train number 12259, 12260, right? So for each T, so first T is equals to 12259 for the first iteration. Now station index will be this particular key. What is the output of this? Train. We'll go to a trains dictionary. For this particular train number 12259, we have gone to this particular train number. Then start is this one. Output is what? Output of this Kolkata. Here you can see, right? So output of train T start is what? Kolkata. Now if I put Kolkata here, so station index corresponding key is Kolkata. The value is 0 here, right? Okay. Any doubt here?
No, sir.
See, what we are doing here. First, we are finding out the value of this particular thing. Trains, T, then N. Trains is a dictionary. Then we are entering this particular dictionary. We are going to this particular key, T. So T is basically a train number. So we are going to from this stage, dictionary to this particular train number. And then we are going to end key. So then we are going to end key here. And the corresponding value is Bikaner. So output of this is Bikaner. So station index in bracket Bikaner, right? So corresponding value will be what? We will go to this particular dictionary, station index, key is Bikaner, and the corresponding value is 1. So answer is 1 here, right? So output is 1 here. Now here we got the value of I and j, that is 0 and 1. Now I and j is 1. So what we are going to do? The matrix that what we have created here, let's say we just have 4 station here. So that will be 4 by 4 matrix. And if you observe in the previous two sessions we have discussed, first corresponding value will be 0 here, right? Then we are updating this particular matrix to what? Ij. So direct of 0, then we have 1. So 0th row, first column, we are going to update it to 1 like this. Okay. And we are doing this for all the station number, train number, right? And in this way, we are going to return this particular direct matrix. So whenever in the matrix, if you see there is 1, it means that starting and ending station X is equals to 1. So for that particular train, like we are creating a matrix for train having the starting and ending station like this. So it will be represented by 1 like this. Okay. So here you can see compile a list of stations from trains, map station to rows and column indices. Yes. And then we have populated the matrix. That's it.
Sir,
Huh?
sorry to interrupt, but this lecture is for week 10 or week 11?
Week 10, lecture 10.4.
Okay, thank you, sir.
Yeah. So at the last, after this pseudocode, what we are going to get? We are going to get the matrix. That is basically direct matrix. And here we will have this 0, 1, 2, 3, whatever the index we have created, 0, 1, 2, 3. And 0 is basically Kolkata, Bikaner, Mumbai, Delhi. So this is Kolkata, Bikaner, Mumbai, Delhi. Here also Kolkata, Bikaner, Mumbai, Delhi. So when I say matrix D 0, 1, when I say matrix D 0, 1, 0th row, first column. Wait, we should have. So 0th row and first column here, right? So 0th row, first column, we are going to update it by 1. Okay, like this, and the rest will be 0. So we are doing this for every train. So we are trying to convert this starting and ending station in the form of matrix. So whenever I see 1 here, it means that there is a train from Kolkata to Bikaner. If I put 1 here, it means that there is a direct train from Mumbai to Mumbai. That is not possible, so it will be 0 diagonal element. But if I put 1 here, it means that second row, third column, so there is a direct train from Mumbai to Delhi like this. Okay, so this matrix will give me the information about the direct train between those two stations whenever there is one. Okay, so this is about this particular pseudocode is doing. Now see, this is what we got from this pseudocode. Now what we're trying to do here. So we are trying to adding information to direct route graph. So station A and B such that trains start at A and ends at B. Yes, we have discussed this. We have populated the matrix. Then we have keep track of trains connecting the station. Each entry in the matrix is now a dictionary, right? So initially empty dictionary, no direct connection. So let's see what this code is doing now. So procedure label direct route trains. So start and rows and column. Are we continuing this code here? What this dot represent?
Sir, that is a direct matrix where we are generating direct matrix in previous code, sir, where
Okay,
there is no
different
stop.
procedure is there. Yeah, yeah.
Yes, sir. Yes, sir.
Different procedure. Yeah. So here we have created a matrix. Now we are consider this particular procedure label direct routes here, right? So here we have trains. Again, we are taking that trains dictionary as an input. For each are in rows of direct. So what is rows of direct here and columns of direct here? Yes, anyone? What this indicates 0, 1, 2, 3, 0, 1, 2, 3. So this is the
Station names, sir.
Station.
yeah.
Starting and
Station,
ending.
that is basically index value, right?
Yes, sir.
So yeah. So I can say index value. So for our example, this will be a list 0, comma 1, comma 2, comma 3. Same for columns as well. And 0 represent that respective station like this. Now what we are doing here, for each r in rows direct, for each columns in direct. So when r equals to 0 initially, and we will keep iterating for inner for loop for c equals to 0. So r0, c0, updating to empty dictionary. Again, value of c will be 1, r0, c1, empty dictionary, r0, c2, empty dictionary, r0, c3, empty dictionary. Then C completed, we'll go to a outer for loop, increment the value of R, like not increment, we'll go for a next index value that is 1, then again R1, again all the values of C. So what we are doing here, inside this particular matrix, what we have created 0, 1, 1, 1, we are updating it by dictionary like this, empty dictionary, empty dictionary, empty dictionary. Any doubt here? What we are doing? We are updating this matrix to empty dictionary now. 0, 1, 2, 3.
Sir, that means we are converting here matrix into dictionary.
The value corresponding to each row and column will be a dictionary now. Okay. Previously it was 0, or if there is direct station, it was 1 here. Right. And now instead of 0 and 1, there is an empty dictionary now for every row and column. Okay. Now what we are doing, once we have created this matrix, say 0, 1, 2, 3, 0, 1, 2, 3. So it is an empty dictionary for all the values inside this matrix. Now for each T in keys of train, again keys of train will be a list of a train number. Now I equals to station index start train T start. So for this particular train number 12259 Kolkata. So we have Kolkata, then value will be 0 and 1. Now what we are doing here, so previously we updated that dictionary to 0 and 1. Now here again, I is 0, J is 1. For the train number 12259, starting is Kolkata and ending station is Bikaner. So 0 and 1. from this station index number, right? Now what we are doing here, direct IJT. So 0th row, first column, the output of this particular thing is an empty dictionary, and we are adding a T, that is key here. So for that particular train number, we are setting this to true. So instead of 1 here, like what we have
Sir, is
decided,
it
0.
just a three-dimensional dictionary sort of thing?
Three-dimensional dictionary.
Yeah, since it's I, J, and T, three keys are there, so that's why.
T
So
is
see,
not a key. It's a key of dictionary inside.
so this is will the output of this will give me the dictionary, and T is the key of this particular dictionary. Okay,
Yes. The
and
train number.
corresponding value is true. So inside that matrix, when we say 0 to 1, so Kolkata to Bikaner, previously it was 1. Now it is an empty dictionary, and inside that dictionary, what we are doing, we are putting the train number now 12259 equals to true here.
True.
Okay. So from this dictionary, I will get to know that Kolkata to Bikaner, we have this particular train number. So direct train exists between Kolkata and Bikaner. Previously, we only know that okay, there is a train exists between Kolkata and Bikaner, direct train, but we don't know which train number. Now, what we are keeping a track of train number also, right? Hello.
Yes, correct, correct.
Yeah. So this is what we are doing for every train number. Okay. And let's say we have multiple train. Again, Kolkata, Bikaner, we have multiple train. Then what will happen in that scenario? So again, that particular dictionary, if we have more than one train also, so that dictionary will get updates. Let's say, for example, 12259 was there, set to
It's
true.
true.
Again, what we are doing? Again, we are going to
Again,
add a different train number, that corresponding train number 0, again set to true here,
true.
right? Like
Yes.
so whenever I get this particular matrix, 0th row, first column, so Kolkata to Bikaner, inside the dictionary, I will get all the information, which are the trains which are running directly from Kolkata to Bikaner. Can I say like this? Right?
Yes.
So in the first pseudocode, we are only keeping a track whether that train exists from these two stations or not. But in the second pseudocode, what we are doing here, we are adding the information to direct route graph. So we're adding information that which train number goes from station A to station B. Okay, this is what's the difference between the first pseudocode and second pseudocode here. Okay. Okay, any issue with the second pseudocode, what we have discussed?
So, in second pseudocode, we are just converting matrix into list of dictionaries. Am I right?
We are not converting matrix, we are changing the value of that matrix to a dictionary. Okay. Matrix is present, but simply we are
Okay.
updating the values. Okay. So previously it was 0, 1, now it is a dictionary here.
Okay, sir.
Yeah. So this is what we are getting from the second pseudocode here. So you can see keep track of trains connecting a station. Each entry in the matrix is now a dictionary. Yes. Initially empty dictionary. Yes. Add a key for each train connecting a pair of station. Yes. This is what we got after executing this particular pseudocode. Okay. Yeah. So what is here? So same thing. Any difference in this? Yeah. So information about train is recorded as labeled on the edges. So age labeled graph. Okay. Yeah. So can anyone tell me what is the meaning of this particular sentence? If you understand about to pseudocode, then we'll proceed further.
Sir, in first pseudocode, we only knew that between the two stations we have a direct route. But now
Hmm.
we are also labeling the label that which train is doing that.
Yes. So 0, 1, 2, 3. So previously I know that there exists a train from 0 to 1. That's it, right? In the graph, it was just 1, right? So if there is age exit between two nodes, so we can say this equals to 1, right? We have discussed this. But now here we are keeping a track of that train number also. 12259 is true, or then whatever 12280 for this. So looking at the graph, I will get to know, okay, from station 0 to 1, there's a direct train, and these are the train numbers here. Previously, it was just equals to 1. So there was a H between two station here, direct IJ equals to 1. Now that information got updated to what? Label on the edges. So that will give me information about the train number here. So you can consider this as I, this as J. Previously, it was just H representing there exists a train, but now we are keeping a track of that train number as well. Okay. So any doubt what we have discussed up till now? First 3 slides, 4 slides. Anyone?
That direct IJT, that value access, normally we will have, you told direct IJ is the key, right? So it is a matrix. From matrix we are collecting.
Yeah. So direct is a matrix. Okay. And here I and J is what? Corresponding
Value.
row and corresponding column. Okay.
Yeah,
So IJ corresponding row, corresponding column, and that T. So output of this direct IJ is what? Dictionary, empty dictionary here, if you observe here, right?
right.
So let's say here for it should be R and C, okay, not IJ here. So for that particular values, here we are keeping output will be empty dictionary, and in that empty dictionary we are adding a T here, right? So T is a key inside this dictionary like this, and the corresponding value will be true like this. Okay. So
So
direct is
T
a
as key, we are collecting the value of train number from that and
yes,
mapping to true, right?
true. Yes, yes. Okay.
Thank you.
So this is our matrix. Okay. So this is about this pseudocode. This is what we are doing. First, we are only keeping a track of whether train exists between two stations or not. So simple age is there. In the second pseudocode, we are also keeping a track of the train numbers that exist between two stations directly. Okay. So this is what we are doing here. Now let's try to find out distance between the stations. So do we have any pseudocode? Okay. So distance between the station. For each direct train, record the distance it travels. So we want to find out the record the distance it travels. So add an extra key. So for that, like in that train dictionary corresponding to that particular train number, we are going to add one extra key, that is distance, and the corresponding value, right? So previously what we have in the trains dictionary is like this. So too many things. So it was 12259. This is Kolkata. So in the let me write it down here. So previously what we have discussed inside the trains dictionary, it was like this. So corresponding train number 12259. It is mapped to a value that is basically a key. It has the uh, station, that is Kolkata set to true, and then Bikaner set to true, right? But now what we are doing, we are also adding train, that corresponding train number, distance. So we are adding one more key here, that is basically a distance. And let's say distance is 800, like this. So this is a dictionary now we are going to consider for the pseudocode. For every train, we are going to add one extra attribute, not attribute, extra key here, that is basically distance. Okay. So this is what this is saying. Compute the shortest distance by direct trains. So trains take different routes between the same pair of station. So what we have said, if we have two trains, let's say 12259 and 12280 going through the station Kolkata and Bikaner, but it may happen that distance is different, right? So in the same dictionary, we have one more thing, let's say 12280. Again, Kolkata is present. True. Again, Bikaner is present. Set to true. And the distance of this train number is different. Let's say 500 kilometers only. Okay. So we have two different trains running on the same route, like maybe a different route, but starting and ending session is same. And here the distance is different, right? Anyone, any doubt up till now what we have discussed?
Sir, why are you adding Kolkata Bikaner, sir? Because it's not asking to include start or end, right? Like only the train number as key and distance should be the key for in a dictionary. What I think is.
Add an extra key here. So we're adding an extra attribute in that, okay? Distance. So
Oh,
train, T and distance like this.
okay,
So
sir.
previously it was only station, right? Now we're adding extra attribute, extra key, that is distance also. Okay.
Okay, sir.
So there can be multiple train going through same starting and ending station, but different routes. So distance will be different like this. Okay. This is what second statement is
Sir,
saying.
so T key here representing a start a station or end station both, right? That's why you are writing here Kolkata and Bikaner.
Can you repeat?
That's the
T
question he was asking.
extra
Because
key.
here is hello.
Sorry. Can you repeat? Yes.
Yeah, so here is the trains is a dictionary.
Hmm.
Under that dictionary, T is a key, and
Hmm.
T key representing train number and also a start station and end station,
Yeah.
right?
Like this.
That's why
Yes.
you are writing here both stations.
Yes. Yeah.
Okay,
And
okay.
now we're adding extra key, that is distance also here, right? Previously we have not considered distance. Previously we just consider this one, starting and ending. That's it, right? Where is train? Yeah. This one, train number, starting and ending only, not the distance. But we are adding one more extra key, distance attribute also. So if you see this scorecard here, we have a distance also like this. Okay, so we are taking this attribute key also. Okay. Now graph direct list, age label direct list is the shortest direct distance between I and J.
There's a question.
Huh?
So following that only. So because we were initialized that train to key to true, right? Mapped to true.
Huh?
But
For a
we are
station
not.
number or station,
Yeah.
yes.
Yeah, previously, but now we added this Kolkata and Bikaner both true and distance. I understood because that distance, but
Hmm.
Kolkata and Bikaner is little confuses here
No,
because
we are
previously it was
considering
true.
this. Yeah, now it's also true, na? Value is true only.
Sir, I think
Uh,
it should be start is to Kolkata and end is to Bikaner. True we mapped in Patience dictionary.
Oh, okay. Here. It should be start and end, right?
Yes, sir.
Yeah.
Yes, sir.
Got it. Thank you. So, okay. Sorry, my bad.
okay, sir. That is
I
what
was,
we were trying to.
uh,
Even
I
he
was
was also
referring,
same asking.
uh,
Yes.
I was referring to a different thing. Start,
Okay.
that is Kolkata, and then we have end, Bikaner. Here also, start is Kolkata and end is Bikaner. Yeah, now it's fine.
Yes, sir.
Yeah, so this is a distance. Yeah, so I was referring to this station. Sorry, so this is a trains dictionary. Yeah. So now let's continue. So this is what we have discussed up till now. Now, what about this graph direct distance, age label direct this is the shortest direct distance between I and J. Okay. So we have a graph by name direct distance, age label inside that graph. So we have I, we have J, we have this arrow is the shortest distance. So label here will be a shortest distance. Let's say I is Kolkata, J is Bikaner, shortest distance is 500, right? So out of these two, which one is shortest? We are keeping a track of that, and that is basically a age label here. So let's see how we are doing that in this pseudo code or not. Yeah. So okay. So up till this you understand, right? This point, second point.
Yes, sir.
Yeah. So let's discuss direct list. So compute the shortest distance first. So direct distance trains. Again, we are taking that key dictionary as an input. Direct distance. So we are creating a matrix here of n by n. So n is what number of station. So we are doing that for each t in keys of train. Again, t is a train number because keys of train is a list of train. I is what? Station 2 index. What is this station 2? It was same as station only. So here what we given the index, same thing. Yeah, so same thing. You can see the continuing that pseudo code. So it was Kolkata 0 and then Bikaner 1, right? Directly is IJ 0, directly is 20, as directly is IJ, minimum distance. And then we are keeping a track of return or dictionary. Okay. So what?
Yes, sir, I have a question regarding this.
Huh?
Regarding the how to find the shortest routes.
Okay.
So the thing is that there might arise situations where a route between A and B might take 500, maybe 500 kilometers long, but I'm just saying.
Hmm.
But a two-way route like from A to C and C to D together, they might take 400 kilometers. So it's like a more shorter route from A to B. So how can we like implement that into the?
Yeah, so we'll discuss. First, we're only discussing about a direct train, right?
Yeah, of course.
Not via any train. Yeah. So we'll discuss the hope concept here. One hope, two hope like this. Here you can see one hope distance. So we'll come to that. As of now, only dealing with the direct train. Okay. So I will come to your question as well. Okay. So for each 10 keys of train, so this is same index. We are creating station to index and the corresponding value like for train T and start is what? So here what? Just a second. Yeah. So let's consider this two only. Station index here. Station to IDX. So what we have considered there? Station number and the index value. So Kolkata 0, then Bikaner was 1, then we have Mumbai 2, then we have Delhi, say 3, right? And then let's say for another train we have Kolkata 4 and Bikaner 5. So have we keep a track of duplicate here for train T? We are simply keeping where it is station index. Station index, yeah, here. So for every station, we are only simply giving the index number and station is what here? Station was this one, Kolkata true, Bikaner true. Okay, so first we have collected and here also we are taking, yeah, that is correct. So here I'm considering three trains, one on different route, like different station. 12260 was from Mumbai and Delhi. Okay. Now this is what station to index is. So what we are doing for each train 12259, station to index, train number 12259, starting is what? Kolkata. So output will be a Kolkata and the Kolkata will be a key and the output corresponding to station to IDX will be what? 0 here, right? So again, this is 0. Similarly, for end station will be 1. Okay. So I and J is 0 and 1. If direct dictionary ij equals to 0, so if there is a exists a direct train ij to 0 equals to 0, then we are doing this. So what does this mean? Yes, anyone? Where direct dictionary represent or graph represent direct, I think it's the
That
shortest
means
direct distance between
there is
I and
no
J.
train between both station, direct train.
Yeah. So if equals to 0 means there is no train between I and J, right? So, but if you see our graph, we have a train, we have considered Bikaner and this Kolkata. So this is not true. If this is not true, then we'll go for else block, right? Because there exists a train between 0 and 1. Now what we are doing here, direct dictionary distance 0, 1, minimum of direct distance 0 and 1. Now train T and distance D. So for that particular train 12259, inside this dictionary, what is the value corresponding to this distance is what it is. So let's say 800 here, right? And here also, first it will be direct dictionary. So we are finding out the minimum distance between two stations here. Simple, right? Yeah, so this is nothing but what we have discussed earlier. We are keeping a track of I is less than equals to mean, then you're updating that I to a mean, right? To finding out the minimum. So same thing we are discussing here. So
Sir,
we're
could you explain direct dictionary one? IJ, how is it holding the like number value, sir? Is it a matrix or a dictionary? Could you explain that once again?
this direct dictionary distance is basically a matrix, okay? So we are, it is a graph, it is given the graph, and we are converting that graph into a adjacency matrix, okay?
Okay, sir. How
And
is
we,
it like storing dictionary? Sorry, if there is a train, then will it store one or zero? Or like if or the distance will it store, sir?
the distance it will store. If there is no
Like
train, then it will be 0. If there's a train, then it
it,
will store the distance.
Sir,
generally, 0 or 1 is being contained in any other
Yeah.
matrices, right? Over here,
So
distance will be stored, right? Right?
no,
Am
initially
I
we
right?
create this matrix, so it will be 0 and 1, right? Initially, if there is a direct train between two I and J, so it will be 1, otherwise it will be 0. So you have created that matrix, initially it was 0 and 1. Whenever there is a train, 1, not train, 0, right? So
Yes,
here
sir.
you can see initially. But now what we are doing, we are checking if there exists a train or not. So I equals to 0. If this is false, then we are going to this particular else block. False will be when it is equals to 1, right? Equals to 1 means
Yes,
what?
sir.
There exists a train between I and J, then we are going to this particular else block. If this condition is true, it means that there is no train between I and J, right?
sir,
Yes, sir.
here
But
till now,
we are
before
updating.
this, if
uh,
sir, before this, if we have not updated, no, direct this ij is equal to 1.
No, here we have
So,
created a matrix, right? Direct this is equal to create matrix
yes,
M
sir.
by N.
So, first, it's all the values are 0 only, right, sir? So, it will enter the first if, right? Direct this ij
Okay.
is equal to 0.
Right. So we have not updated here. So what we are considering this dot here.
Sir, I have a question.
Huh?
Can you please show that thing, the distance, finding the minimum distance?
Just a second. So that dot represent we are continuing the previous pseudocode, right?
So, dot is index mapping. After the index mapping of all the station we are doing.
We are mapping the index, but that already we have done again. Station to index here, right? So
Sir, there we are not mapping,
not
no, sir.
updating.
We have already mapped in station index. That's why we are able to fetch this train T start
Hmm.
Kolkata.
Yeah. So yeah, so here we have not updated the dictionary here. So it will be 0 only initially. And yeah, so previously we have updated, right? Let me check. When we create a matrix, we have it was 0. Then we have updated to 0 1 here, right? But we are
Yes,
not
sir.
considering this pseudocode here. Okay. Okay, so anyone has watched the lecture, what professor has said about this dot dot, what we are considering from previous pseudocode?
Sir, index mapping. We create this
Index mapping
matrix,
only.
map
Okay.
all the station to the index, unique
Huh.
index.
So we are
Then
finding
we,
out this station to index only here, right?
yes, sir, yes, sir.
Okay, okay, yeah. Okay, so we are not updating a dictionary. So yeah. So here, if we create a dictionary, so initially all will be zero, and here we are not updating that dictionary. Sorry, matrix here, right? Direct dictionaries. Now what we are doing here for each train in keys of train. So same thing, train number 12259. Index we have created from that previous pseudocode. So that will be 0 and this will be 1. 0 for Kolkata, 1 for Bikaner. Then if direct dictionary I, J equals to 0. So if there is exists a train between I and J, so since it was 0 for all the stations, now what we are going to do? Direct list IJ. So 0, 1. So 0th row, first column. Trains T. So for that particular train T, distance we are going to cover. Yeah, that is correct now. Yes. So see here, consider this particular station to index, this particular thing, and this train. Okay. So first, based on this train number, we have taken the Kolkata. So index value is 0. So 0, I is 0. Then end station is Bikaner, index value is 1. Okay. So here we got I 0 and J equals to 1. Output of this thing, same what we have discussed earlier. Now, if direct distance I, J equals to 0. So while creation of this matrix, initially all are 0. We have not updated anything here, right? Now, 0 to 1, so there equals to 0. That is true initially. Now, what we are going to do, we are going to update the value 0 to 1, and then corresponding value will be what? Trains T. So for that particular train number, distance. So we are going for that train number, trains, train number, and then distance is what? 800. So then we are keeping equals to 800. So what will happen here like this? 0, 1, 2, 3, 4, 5. Again 0, 1, 2, 3, 4, 5. And let's assume everything is 0 first.
Sir, I have a question like regarding this.
Uh,
The it is saying that if direct dictionary ij is equal to 0.
Direct distance, this is a matrix, okay? This is a matrix, and then 0th row, first column. Ith row, jth column equals to 0.
Okay, so how are we understanding that they are connected they are in fact connected and thus they should be updated with the distance between the trains?
No, we are only checking direct distance equals to 0 for those thing, okay?
Okay, so it's basically I and J. Okay, okay. I and J are like updated for the specific train.
So here I and J we are taking from that particular train number, okay? So this is what it is, 0 and 1. So initially it was 0. Now we are updating this to 800. Okay, this will be a 800. Okay. Okay. Anyone, any doubt what we have done here?
Sir, I have a doubt. If there is direct distance ij equivalent to 0, that means there is no direct train between I and j, right? And if there is no direct train between I and j, then how can we put
No, no.
the value
We are
distance 800?
no here. Once we create a dictionary, first create matrix n by n. Initially, for all the station, corresponding value is 0, 0 only. Once we have created this dictionary, so it will be 0, 0 only. We have not
That means
updated this to
empty.
1. Yeah,
Okay,
empty.
empty.
So what we have discussed earlier, so for that we have a pseudocode corresponding to that. So here is that pseudocode. So for that particular matrix, we are updating it to 1 here, right? But this is
Mhm.
pseudocode is not present there, right? So
Mhm.
initially all are 0, okay? And now what we are doing for that train number, those station, we are updating it to the corresponding distance, that is 800 here, right? So that's it. We don't need to go to else block. We'll go for a next for loop. Next train number. Next train number is what? 12260. Okay.
So in this condition, there is no need to go in else block, code block, because everything is zero. So
Yes.
there is no need to go
No.
in else block.
Yeah, no need to go to else block. We'll discuss that also, because here we have one more train. So we have considered three trains here: 12259, 12280, and 12260 from previous thing only. That is Mumbai and Delhi. So Mumbai, like, starting is Mumbai and ending is that one. Okay, so starting is Mumbai, ending is Delhi, and let's say distance is basically 700 here. Okay, so now I will go with this second train. So first train, second train, and we have third train. So as of now, we just have three trains in this trains dictionary. So we have done with 12259. Let's go with 12260. That is Mumbai and Delhi. Distance is 7. Okay. Now again, we are going for that particular train number 12260. So trains dictionary 12260, starting is Mumbai, and the index corresponding to that Mumbai is what? Index corresponding to Mumbai is what? 2, and for Delhi it is 3. So index corresponding to Mumbai is what? 2, and this is 3. So again 2, 3, initially 0. So we are updating that to that corresponding distance, that is basically 700. So second row, third column is what? 700 here, right? Now station index, where is station index we have created? Yeah. This is how we have created the station index. So for each keys of station, so keys of station. What is station here? List of the stations, right? So that we calculated here. Okay. Yeah. So we have considered this one previously. So station will be what? For that train number, for every train, we are putting this station equals to 2. Okay. So yeah, then what we are doing, station index. Okay. For S in keys of a station. Okay. Here, to compare the distance, we need to go through this else block. But for that, your station index must be same here, right? So each label graph, we discover direct route for the first time shade distance. Okay, then each label graph direct. Each label graph we will discover direct route for the first time shade distance. Yes, if we find new direct route, we already directed, update the distance to the minimum one. Yeah, this is what we are doing in the else block here. Yeah, so see, if we have a second train, okay, so for a second train, that is 12260, we have updated to 700, that is correct here. But if you see the station index, Kolkata and Bikaner should have the same index value 0 or 1. But that should get reflected in the station index, right? Otherwise, again, that will be get updated here. So station index is what we have created Station index already we have created here. Are you getting my point? What I am saying? So there should be like for Kolkata, there only should be one index value, not more, right? Station index empty additionally I0 for S in keys of station. So again, Kolkata came. That will be a different one. No? Keys of station. Station is train number again starting. Ending is
Sir, each station will be mapped only once, right?
oh yes. Here, right?
Yes, sir.
Station starting to because in the
Stations
dictionary
is a
key is unique.
dictionary. Yes, sir.
Yeah, key is unique here, right? So this is correct till here, but if I take one more, yeah, let me discuss it here only. So we are coming back to previous pseudocode only here, this one. So we have just considered two train here, 12259, 12260, but we have not considered duplicate one that we have considered later. Now, if I consider one more train, 12280, 12280, same thing, Kolkata and Bikaner, distance is 500. So what will happen here for that particular train number? So for that particular train, train T and start again Kolkata is set to true. But if you observe, this station is what? Dictionary. So here keys are unique, right? So only Kolkata and Bikaner will be there. So in the list of the keys, there will no repetition will be there. Only Kolkata and Bikaner will be there. And then if we take the index value, it will be 0 and 1 only. Okay, good. Very good doubt. Okay. Are you getting my point? What I am saying? What I am saying?
Yes, sir.
Hello? See, we
No,
have
sir.
one more station passing through the same starting and ending station. So what we are doing here for that particular train number 12280, again starting is Kolkata set to true. But if you observe from the previous 12259, already Kolkata is present inside inside a dictionary. So duplicate keys are not allowed. Key is always unique in the dictionary, right? So Kolkata is set to true only. So we are not updating here. Kolkata is equals to true. So anyway, same thing here. Now when I take keys of station here, so here Kolkata will be and Bikaner will be unique only. So here it was 0 and 1 only, right? So here we don't need to consider this thing. This is only required. Okay. So index 0 to Kolkata and Bikaner to 1. Now if I go for 12280 here for a next station 12280 next train number, what will happen? 12280. So keys of train same. We are taking this from this thing. Index number for this particular train starting is what? Kolkata, that is 0. Ending is what? Bikaner, that is 1. Now, is this condition true now? 0, comma 1, 0, 1 equals to 0. Is this true now for train number 12280? Zeroth row,
No, sir.
zeroth
No,
row,
sir.
first column. It is 800, right? Now, that is not equals to 0. Then we'll go for a else block here. Now, what we are doing in the else block? Direct dictionary. So, 0 and 1. We are finding out the minimum of this one. So direct distance I to j from the previous distance, that is 800, and for that corresponding train and distance is what? 500. 500, no? Yes, 500, and minimum of this is what we are going to take, that is 500. Output will be 500 here. So we are updating that particular direct dist to 500. So instead of 800, that will be 500. So in this way, we are keeping a track of the distance, like smallest distance. Okay, so shortest distance between the trains. So this is the code. Okay, any doubt now? Anyone? Sorry for that confusion. Because we need to take the previous pseudocode. So I missed that one. Yeah. Any doubt? Shall I explain it again?
Yes,
Yes,
the
sir. Please
confusion
Yes, sir.
part, can you come again,
Okay.
please?
Okay.
Please explain again.
So, but for this, you should understand the previous first pseudocode, how we are calculating the station and index dictionary, right? So this is what it is saying. We need to consider the previous one. So, if you observe here, what we are doing, we have three train 12260, 12259, 60, and 80, right? So here, if you observe, for each train, we are creating a dictionary station. Inside that, we are putting a station name equals to true. So Kolkata true, Bikaner true, like this. Going for a next train, that is 12260, Mumbai true, Mumbai true, Delhi true. Again, if I go for a next train 12280, Kolkata and Bikaner, but if you observe station Kolkata, right? But already we have Kolkata here and then updating the value to true. So anyway, same thing here. Kolkata equals to true. Again, Bikaner equals to true. So even if we have multiple train inside the station dictionary, Kolkata will be true, Bikaner will be true, like this. So we are only simply going through this and we're updating this to true, right? So same thing here. So this
If
is about
a
the
second
station.
train comes, we are updating the value, right?
Again, suppose
If
different
another
train,
train comes,
another train comes to same station. Anyway, we are setting it to true, right? So same thing here, true only, right?
okay.
Yeah. So in this way, we are putting a station name inside the station's dictionary. Now here we are creating a matrix, empty matrix. So okay, but here you have to focus station index. What we are doing here, initially it is empty, I equals to 0 for each as in keys of station. Keys of station is Kolkata, Bikaner, Mumbai, Delhi. We are giving the index value here. So Kolkata 0, Bikaner 1, Mumbai 2, Delhi 3. Even if you have multiple trains running through Kolkata and Bikaner, index value will remain same. Okay. So this is what about the station and index dictionary. Any doubt here?
No.
Okay. Now, if you understand this, let's go back to here. So this is what we got. Now we are creating a matrix, direct distance, create matrix. Initially, all values will be 0. Okay, so everything is 0 here. You can see for every thing, it will be only 0, 3, 1, 2, 3, 4 by 4 matrix only. We are just considering the 4 station here like this. Okay, so initially all are 0. And 0, 1, 2, 3 represent the station like Kolkata, Bikaner, Mumbai, Delhi, according to the index value here. Now, what we are doing here, for each T in keys of train, first 12259, Kolkata, Bikaner. So, index train T. So, 12259 start. Again, train 12259 start. Train 12259 and start will be what? Kolkata here. So train 12259 start, output is Kolkata. And this is we are going to take as input for this dictionary. Station to index Kolkata is basically equals to 0. The value is 0 here. So output of this is what? Kolkata, and output of this station to index Kolkata is what? 0. Similarly, here output of entire thing is what? Here it is Bikaner and station to index is what? 1. Now I is 0, j is 1. So 0 and 1. Is this condition true for the first iteration? Yes. 0th row, first column, 0 is the answer, 0 is the value. So this is true. Now we are going for direct this 0 and 1. So we are going to update this particular matrix now for 0th row and first column to what? Train T. What is T? 12259. What is distance? So distance for this train number is 800. So we are going to update that particular value to 800 here. So let's update that to 800. Okay. Any doubt what we have discussed up till now?
No, sir.
Okay. Now we will not go to else block. We go for a next iteration, next train number 12260. That is basically what? Mumbai and Delhi. So Mumbai, Delhi, Mumbai ending Delhi, distance 700, and corresponding index is what? 2 and 3. So same thing here for that particular 12260, corresponding index is what? 2 and 3. So in similar fashion, I will be 2, J will be 3. Now what about this direct distance 2, 3? Check the matrix. Is this true now? Second row, third column. This is 0, right? Now this is true. If this is true, again we are going to update this direct distance 0, sorry, 2, 3. Train 12260, corresponding distance is what? 700. So we are going to update this particular 0 to 700 now. 0, this will be 700, right? Updated one. Now go back to again for loop. Now here, see, next train is what? 12280. Now here, see carefully, 12280. Again, starting is Kolkata, corresponding index is 0, ending is Bikaner, corresponding index is 1. So I is 0 and j is 1, 0 and 1. Now tell me if this if condition is true, direct distance 0 and 1 now. Is this true? Zeroth row, first column, it is 800, right?
not
Not
true.
true. So we will go for else block here now. Now direct distance 0 and 1, we are going to update the value to what? Minimum of this. So direct distance 0, 1, what is the current value? 800, comma, train T. So we'll go to this particular train, tree T. So what is that? 12280. Corresponding distance is what? 500. So distance is what? 500. Output of this will be 500, and minimum function will give me minimum value 800 or 500. That is basically 500. So we are going to update the distance 0 and 1 to 500. So instead of 800, that will get updated to 500 here, right? So in this way, 0th row, first column will be what? 500 here. Okay. So in this way, we are keeping a track of shortest distance between two stations here. Anyone, any doubt now? So here you can see we discover a direct route for the first time, set the distance. So whenever we discover the route for the first time, we are setting a distance. If we find a new direct route between an already connected pair, update the distance to minimum. If you already found the train, then we will go to a else block and will update the distance. That is a minimum one. Okay, this is what we are doing here. Okay. Okay. Anyone, any doubt now?
No, sir,
Sir,
it's
what is
clear.
direct list? Directed list.
Direct distance is matrix. So we are creating a matrix to keep a track of a shortest distance. So here you can see initially all values are 0 for that particular station, corresponding station number, and then we are updating it here like this. So direct distance is this particular matrix that what I have drawn here, this one. Okay, and 0, 1, 2, 3 represent the station number, right? So it means that in this pseudocode, if we have 0 and 1, that is Kolkata and Mumbai, we have an arrow and corresponding label will be a shortest distance between this one. So first we have discussed 0 and 1. So we are keeping a track of only trains are there or not. In the second pseudocode, we are keeping a track of which trains are there in the form of dictionary 12259, 12280 like this. And here what we have discussed, we are keeping a track of shortest distance between 0 and 1. Okay. So we have discussed 3 pseudocode here. Each of procedure doing a different thing. Okay. Anyone, any doubt? So do one thing. Once the session is over, take 4 train number, any train number such that out of 3 are same and 1 is different, or 2 are same, 2 are different. You can take different example and different distance and try to execute that on all the pseudocode. Okay, and see whether you are getting the same thing or not. Okay, just change the example and try to execute this pseudocode. So when you solve this pseudocode, you are going to understand in a better way. Okay.
Here, the last one we discussed. So
Uh,
this equal to 0, right? So initially it was everything rows and columns are 0. So we are
yes.
enter as everything as 0.
0. Yes.
Okay. Once we are updating it, it's set to be that particular train's distance. For example, 800. So then we are passing the same route train So it will be checking whether it is not 0. It will be 800, right?
Yeah. So this
It
is
is
not
equal to,
true. Yeah.
yeah. So because I thought it is 1. No, no. It is 800 that time.
Yeah.
Okay, got it.
Yeah. So in the first pseudocode, we have updated matrix to 0 or 1. The second pseudocode, we have updated to dictionary. In the third pseudocode, we are updating that matrix to distance. Okay.
Got it. Got it.
Yeah. So that's what I said. Please take one example, like 3 different trains, and try to execute this again. Okay. When you go through by your own, you can understand in a better way. Okay. So this is about what we have discussed up till now, and it's a direct train between two station A and B. Now we have one hope distance. Okay. Now let's discuss this one hope distance. Same pseudocode is there. Yeah, and everything is present on this slide. Okay, so we'll discuss what is this one hope distance is. So we start the matrix of direct distance. So we are starting with the matrix of direct distances, right? So procedure one hope distance direct dist and is length of keys of direct list. So keys of direct list is basically a station only, number of stations, right? So one hope is create a matrix. So number of stations, you're creating a matrix. So here you can see again, one hope will have a matrix that is all 0, right? We have simply created a
Sir,
matrix.
what is hope, sir? Hope distance. What is hope distance?
So this is a procedure. We are trying to find out what this procedure is doing. Okay. Once we go through, we'll get to know what this is one hope distance is. Okay. So one hope distance is what image what we can say if I'm going from Mumbai to Pune and then Pune to Delhi, so I'm going via Pune, right? So one hope distance. So there is one intermediate station between Mumbai and Delhi like this. So we'll see how this pseudocode is working. So create matrix for each I in rows of direct distance, for each j in columns of direct distance. Then what we are doing for every I and j value, one hope distance is equals to what? Direct distance I and j. Okay. So here what we are doing. So direct distance, we want to keep a track of this one. Each time we discover one hope road, topic rows one. Yeah. Let's take one example that will be better, but let's go to pseudocode here first. So we are updating that particular corresponding value to the value present in this particular direct dist one, right? Then what we are doing for each k in columns of direct distance I comma k, okay? So I is what in this row greater than 0 and k to j greater than 0. Then what we are doing, new distance is what? Direct I to k, k to 0, okay? So here, see, whatever example we have taken here, where it is for previous example. Yeah, so here we have two train, but let's take, because we want intermediate station as well here. So direct distance is covering that thing only. Mumbai to Delhi. Let's say we are going Kolkata. Okay, so you understand this direct distance, how we are getting a shortest distance. So using that only, I'm creating one dictionary, but here it is a different one. Let's say station index. Same thing, Kolkata 0, Bikaner 1, Mumbai 2, Delhi 3, Kolkata to Bikaner, Bikaner to Delhi we want. Then we can say Kolkata to Delhi like this. So let's say we have one more train 12281 that is going from Bikaner to Delhi. Bikaner is the starting station, Delhi is the ending station. And let's see. 500, right? Bikaner, and let's see, it is 200 distance. Okay, so distance is 200. So Bikaner will be 1, Delhi will be 3. So in that case, zeroth row and first column, sorry, which column? Third column. Zeroth row and third column will be what? Update to 500, not 500, 200. Okay, are you getting what I'm doing here? No.
In between direct path and one hope, which is the shortest, right?
No, see, continuing to that same 3 train, we are considering one more train,
So
1
there
to
should
2
be Bikaner to Delhi, Bikaner to Mumbai, I think. 12281 should be from Bikaner to Mumbai. Then only three train would be connecting from
Yeah,
intermediate
you can
station.
consider Mumbai or Delhi also. Kolkata, Bikaner, or Bikaner, Delhi. So we can go to Kolkata and Delhi like this. Kolkata, Bikaner, Bikaner, Mumbai. And we are going from Kolkata to Mumbai like this. Then,
Okay, okay.
yeah, one hope, right? So this is Kolkata, Bikaner. So one hope. Kolkata 0, Bikaner 1. We need to consider two more things here. So first we are going through a direct route, Kolkata and Bikaner. And let's see, we are going to Kolkata and then Delhi, or let's say Mumbai, for example. Kolkata, Mumbai, distance 200. And we have one more train 822, Mumbai to Bikaner. Okay, instead of writing, let me do one more thing. That will be good.
Your screen is not visible.
Yes, just a second. This is not that. Okay, is my entire screen visible? This notepad visible?
Yes, sir.
Yeah. So
No, sir.
let's, no, not visible? Yeah, okay.
It's
Yes,
visible, sir.
Yes, sir, it's visible.
So let's create the dictionary. Same thing, 12259. Then we have this. I'm not writing directly. So start is what? Kolkata. End is what? Bikaner, and distance is basically 500. And then two 60 was that was Mumbai and was Delhi 700. 12280 was start Kolkata, Bikaner, distance. Okay. Previously it was 800, then it got updated to 500. Okay. Now 12281. So let's start with Kolkata, but end with Mumbai. Distance 500. 500 में इसको करते हैं 150, right? And we have one more train 12282, that is from Kolkata, Mumbai to Bikaner. Mumbai to Bikaner, and distance is, let's say, 300 here. Okay, is font is visible for
Yes,
this?
sir.
Yeah, okay. Okay, so this is a train dictionary we have. Now from this train dictionary, if I create a station index, STNIDX, so that will be what? So it should be equal to. So here we have Kolkata 0, then we have Bikaner 1, then Mumbai 2, Delhi 3. Any other? No. Okay. So this is what we got. Okay. Now let's go back to our this pseudo code here. Okay, see, now one hop distance, direct distance. So if I just consider this station index and train number, our matrix will be what? Our matrix will look like this. So matrix, let me write it down here, matrix for that train. So 0, 1, 2, 3, 0, 1, 2, 3. Okay. So this diagonal will be 0. So if you see this particular matrix, so Kolkata, Bikaner, so we are keeping a track of shortest distance, right? So 0 and 1 was 500. So this was 500. Then we have train from Mumbai, Delhi, that is Mumbai, Delhi 23. 23 is what? 700. 23 is what? 700. Then we have train from Kolkata to Mumbai. So Kolkata, Mumbai 0 and 2. 0, 2 will be 150. So 0, 2 will be 150. And then we have uh, Mumbai to Bikaner. And that is what? 2 to 1. 2, 1 will be 300. So 2, 1 will be 300. Okay. So this is what we will get after direct distance after applying the previous pseudocode here. Okay. Any doubt? I have just added two more train and then apply the same pseudocode what we have discussed earlier. Okay. So this is what we are going to get. Now let's see. One hop distance. Keys of direct dictionary is what we have 4. And hop create matrix 4 by 4 matrix again. So one hop list distance. So again 4 by 4 matrix same, but everything is 0 here. Okay.
Sir,
For
how
each
01 is 500, 02 is 150.
No, we are considering two more trains. So 0th row and second row. So 150 is what? Distance between Kolkata and Mumbai is what? 150. So Kolkata is 0 index and
Okay, sir. Understood.
Mumbai is what?
Understood.
2. So second row,
Yes, sir. Okay. By
0th row.
index, station index.
Yeah,
Yes,
index.
sir.
Yeah. This
Thank
is
you,
what
sir.
we got from the previous pseudocode here. What we have discussed. Okay. This one. Direct distance. We applied that procedure and we got this one. Now what we are doing here for I and j, so rows and columns will be same 0, 2, 1, 2, 3, 4. Same for columns here. One hop distance for I and j equals to direct ij. So first I0 for will iterating through j, so j equals to 0. 0, 0 will be 0, 0 only. So let me create one more thing here. Where to write? Here to write. So one hope distance, one hope distance, 0, 1, 2, 3, again 0, 1, 2, 3. Assume that initially all are 0. So what we are doing here for 0, 0 and here also 0, 0. Corresponding value is 0 only. So we are going to update there 0 like this. For next will be j equals to 1. So 0, I0, j1 equals to 0 and j, right? Okay, let's continue that one first. So 0, 0, we are updated to this. Now for each k in columns of direct list, is also again 0, 1, 2, 3. If 0 to k, 0 to 0 greater than 0, so that is anyway false, right? If this is false, then we are not going to do anything. We go back to a next for loop. Again, k is what? 1. So 0 to 1 is there a distance? Yes. So if you observe here, 0 and 1 in the direct distance is greater than 0, right? 0, 1 is greater than 0, 500, that is true. And direct distance is what? 1 and j. J is what? 0 here. So 0 to 1, 1 to 0. 1 to 0, is there any distance? 1 and 0? No. That is again false. So we'll go to a next iteration again. So what we are doing here? Yes, can anyone tell me what we are doing here? What this condition is telling us here? This only.
Hope.
Tell me what if condition is checking.
There is
Sir, it is not equal, sir. Sir, I and j, sir. You have taken 1 to 0 and 0 to 1. It's not. Oh, it's different, right, sir? I and j are not equal.
No. So initially I will be 0, j will be 0, right?
Yes, sir.
So 0, 0, 0, 0. So whatever the value we got here, that is 0, we are going to update in the one hop dictionary, right? Matrix. That is correct.
Yes, sir.
Then go for a for each k in columns of this one. Again, it will start from 0 to 1, 2, 3. So here also k is 0. So all are 0, 0 like this.
Yes, sir.
Anyway, this is not true because distance is not greater than 0. So we go for a next iteration because we have to complete first inner for loop. Now k, we have to change, keep I and j equals to 0. So k will be 1. So 0 to 1, yes, but 1 to 0, that is not there, right? Again for next iteration, k will be 2, I and j will be 0 only. Unless we complete this inner for loop, we are not going for outer for loop for j. Unless we complete j for loop, we are not going for outer for loop of I. Are you getting my point?
Got it, sir. Yes, sir.
So what this is saying, tell me, what do you understand by this condition?
Is there any in between station?
connect. Yeah.
I to k, if I to k greater than 0 means what? There exists some train,
Yes, sir.
Yes.
whatever the distance might be, let's say 200. And k to j, I have j one more node, there exists a train from k to j greater than 0, let's say for 100, right? Now, if this condition is true, if we have a train from I to k and k to j, then what we are doing here?
Connected train like Delhi to Mumbai or Mumbai to Bikaner.
Yeah. So
Delhi.
what we are going to do, new distance equals to direct distance I to k. I to k plus
200.
direct distance k to j, right? So 200 plus 100 is what? 300, right? If
Yes, sir.
one hope distance, now in that dictionary ij, so I is this one, j is this one, is greater than 0. We are checking it is greater than 0. If there exists a direct train between I and j, then it will be true. But if not, then we go for else block, and then we are going to update that to a new distance, that is 300 here. Okay, so till this you understand about new dist, what is the value of how we got 300?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, so if condition will be true only when there exists a train from I to k and k to j, I to k and k to j, then only if condition will be true, because and thing is there, both the condition must satisfy. Now, if this is true, what we are going to do, new distance we are calculating such that distance between this two node and this two node. So if I'm going from Kolkata to what we have considered? Yeah, if I'm going from Kolkata to Mumbai and then Mumbai to Bikaner, so I can update Kolkata to Bikaner distance to 300 like this. This is what we are going to say here. Let's see how it works. So we are calculated new distance here, that is 300. Now, if one hope distance I and j, Okay. Now let's take the value here because we don't need to iterate for all the things. Let's consider I equals to 0 and j equals to 1. So I 0 and the j 1 when the iteration will reach at this particular point, what will happen now? Tell me. I 0 and j 1, what will happen now? Tell me.
That is saying a direct train between I and J.
Yeah. No. Here we are just considering value of I to 0, j to 1. And now at this particular line, what we are doing, one hop distance 0 and 1 equals to direct distance 0 and 1. The output of this is what? 0 and 1 is 500 here. You can see, right? So this will be
Yes.
500 and we are going to update this in one hop distance. That is what here we are going to update in this particular dictionary. Okay, let me, we have updated this one. Now, okay. Now for each k, now k will vary from 0 to 3. Okay, columns of direct distance. If direct distance, so I is fixed, that is 0, j is fixed, that is 1. K is what? So what value of k, both the condition will be true? Tell me now, for what value of k in this particular direct dictionary, direct distance, which both the condition will be true. For which value of k? 0, 1, 2, 3. Just look at this particular matrix and tell me.
Can you please repeat, sir?
None, sir.
For what value of k, for which value of k, both the condition will be true.
0, 1 and 1
For
and
2,
1.
K equal to 2, 150.
When I say k equals to 2,
2,
so
yes.
0 to 2 is what? 0 through second column greater than 0? Yes. And second row, first column greater than 0? Yes. Now what we are going, new distance is what? New distance I to k 0 to, that is 150, plus direct distance k to j, that is 300, is what? 450 here.
450, sir.
Now
450.
what we are doing here, if one hop distance, okay, one hop distance I and j is what? 0 to greater than 0. Now go back to one hop distance 0 to. Do we have any distance 0 to here? It is initially 0. Sorry, j is 1. Sorry.
It should be 0 to 1. It should be
Yeah.
0 to 1.
J
So
is
it
1.
would be
Yeah.
500.
So 0 to 1, that is 500 here, right? Now this is true. This condition is true for j equals to 1 and I equals to 0 for one hop dictionary. Now if this is true, what we are doing here? One hop distance 0 and 1, minimum of new distance is what? 450. Original distance is what? 500. So minimum of this what? 450. So we are going to update that to 450 here. Instead of 500, that will be 450. Okay. And then we are doing this for every station. This is what one hop distance is. We are finding out whether we can reach that particular station with one intermediate station or not. And then we are finding out the summation of that. Okay, distance. If that distance is greater, let's say for example, here, where is that dictionary? Yeah. Here, if I say instead of 150, it is 250. In that scenario, 250 plus 300 will be 550, and that is not a minimum one, so it will be 500 only. Okay. So in this way, we are keeping a track of what? Minimum distance, shortest distance, but we are considering one hop distance as well here, not the direct one. So previously we are only considering Kolkata to Bikaner. Do we have any direct train or not? Now what we have considered Kolkata to Mumbai and via Mumbai to Bikaner. Okay. So this is what we have calculated. First I am going to Mumbai, 150 kilometer, Mumbai to Bikaner, 300 kilometer, and total Kolkata to Bikaner is what? 450 kilometers. This is how we got updated to 450 here. Okay. So that is what one hop here, one intermediate station between Kolkata and Bikaner. Okay. Anyone, any doubt here?
Sir,
Huh?
Sir, this is at most one hop distance, right?
At most one hop, yeah, at most one hop. So yeah, either there can be a direct train as well as one intermediate station. Yeah.
Okay.
If there is no intermediate station, for example, like what we have discussed, Mumbai and Delhi. In this dictionary, we don't have Mumbai to Bikaner, we don't have Bikaner to Delhi, right? So in that scenario, here you can see that condition, right? So whatever the value we have in a direct dictionary, that will be present in that as well directly. Okay. So that is
Okay.
700 for this. Yeah.
So, sir, it will be updating the shortest distance at most
Yes.
one hop.
Yeah, at most one hop. We are updating a shortest distance between two stations. If we are if we can reach via intermediate station or not. So someone asked before if I can go to Kolkata and Bikaner via different route, maybe some Mumbai. So how we are going to do that? This is what we have discussed now.
Even if the distance in one hop is more than the direct distance, we can consider it as one hop. But here we are considering the shortest distance, right?
Yeah. Yeah. So that is one hope. That is correct. But if we take a summation, if that summation is more, then we are not going to update that to highest distance because we want to find out minimum distance here, right?
Yeah, in
That's
this
it.
particular program, we are not considering it, we are considering like that.
Yes,
Otherwise,
yes.
also, if there is in between station and we have another train, we can consider it as one hop, right?
One hope means only we have one intermediate station. Kolkata to Mumbai, Mumbai to Bikaner. That is one hope. Okay. If I say Kolkata to Mumbai, Mumbai to Delhi, and Delhi to Bikaner, that will be two hope.
Yes. What I'm asking is, if
Ah.
stations are in between connecting to other stations, it is considered as one hop. Distance is the second criteria, whether we want to consider or not, right?
Yeah, for this pseudocode, yeah. Here we are saying, right, minimum distance. Yeah.
Yeah.
Yeah. And here we are checking whether there exists a train such that we have one intermediate station, I to K, K to J. Okay. And if I want to find out for two hop, what changes I have to do here? Yes, anyone?
Sir, one hop dist ik greater than 0 and then direct. And we will store one hop dist inside this two hop dist at first.
No, here I need to add one more condition and direct distance J to M. Okay. If that is also greater than 0, then we can say I to K, K to J, and J to M.
Sir,
Okay.
if we are
Sir,
having one
first
hop distance,
condition we can check in one hop.
Sorry, can you repeat?
yes, sir. Yes, sir. He's telling right. Please continue, Kishore.
Sir, if one hop direct dist ik greater than 0, then first we'll go by one hop and then we will check by direct. Then automatically it will become two hop.
Okay, so you mean to say first we are going for K to like Kolkata to Mumbai, Mumbai to Delhi, and then in the next thing we are checking for Delhi to Bikaner, like
Yes,
this.
sir. Yes, sir. Yes, sir. Correct.
Yeah, yeah, that is also correct. Yeah. So if I add one more if condition here, and in that I mention J to M, that is also correct. Or if I add one more and that mention, that is also correct. Yes.
Sir, if we add more and condition, then the serial should be direct distance I to K, and then direct distance K to M, and then direct distance M to J.
Yeah, that is
Am I
also
right?
fine. I to J, yes, yeah. If we go in that way. But here we need to add one more for loop for M. Okay. Here we need to add one more for loop for M, and then we need to write for each M in columns or rows of direct dictionary, and then we are doing that. Because M will also vary from same 0 to 1 to 3, right? So one more for loop is required and extra condition is required for two hop distance. Okay, great. So anyway, any doubt now? Again, I am saying after the session, maybe tomorrow you can try this out. just take this as an input and just try to execute on all the pseudocode what we have discussed today. Okay. So here I'm explaining, that's why it looks easy, but when you try, you can again, you may found some new doubt, right? So please do it your own. Okay, anyone, any other doubt now here in this week or any other week? So
Sir, in our syllabus, there is also pseudocode for two hop distance, minimum two hop distance. So, can you
we have where it is?
um,
Can you tell me the
not in
lecture?
that? I think.
That is
Still in
10.3, sir.
10.3.
10.3. Direct route, direct route. Let me. Okay, I think my entire screen is visible. Point. So yeah, so we have to discuss this first, then we can go for 10.4. But this is already discussed in the previous session, right? That's why I went directly for that. So here you can see two hope route. N keys. So n is what? Number of station. Two hope create matrix for each I in rows, for each j in columns. So first we are checking for ij, two hope I to j, for each k in columns direct, I to k and k to j. Okay. So here what we are doing, I to j. Okay. So we are updating directly. Then I to k, k to j. Then we have saying two hope equals to 1. Where is one hope? Good.
So two hops means that is two intermediate station between start and end, right?
At most one hope. Yeah. Two hope means at most two hope. So two intermediate station. Start and end, but yeah. I to k, k to j. This is I to
So
k, k
here
to
should be
j.
more variable, J to M, maybe I to K, K to M, and M to J.
So I j. So we are checking. We are updating that distance. Then for k in columns I to k, k to j. Here I to k, k to j, I to j, I j. We are updating I to k, k to j. Discovering the k, k to j, I to j. Yeah, there should be one more thing here. Discovering the check the slides. Oh, okay, okay, got it. Name is different there. Yeah, get this. Sorry. Yeah, so here name is different, not direct one. So you can see one hope and this is direct, right? Not direct here, right? So if you observe what we are saying here, if I can go to I to K via one hope and then K to J, then we can say we are going to I to J via two hope. Okay. Hello.
Yes.
Yes, sir.
Yes,
If you
sir.
want one more variable, so what you have to do, you need to introduce yum, update this to direct, then you can say I to K, K to J, and then again direct J to M. So in this way you can do that, but what professor has discussed here, so instead of going to this, first we are going for one hope, and then we are checking we can go to another station from that particular case station here, right? So here it is one hope, not the direct one. So in the previous code, here we are checking direct, right? So I can go to I to K, then K to J. This is what we are checking here, right? It's a direct matrix. In the second one, what we are doing, we are using the previous one what we have created one hope, and that is basically equals to 1. If I can go from I to K via one hope and then K to J via one station, then I can say I can go via two hope. Yes. Okay. So here you can see, please be careful with this such thing. So one hope direct here. Okay. Okay. Anyone, any doubt now? This is about the two hope. This is also correct. And what I said, we require one more for loop and then introduce one more variable m. So for that again direct, and again one more direct. So in that way I to K, K to J, J to M. Okay, so that will be the case. Yes. But here we are going via one hop, then we are checking for direct train.
Sir, here one hop already includes one extra station, so that's why we are
Yes.
checking.
Yes,
Okay, yes.
already include extra station. So I am reaching I to K via one intermediate station here. Let's say M. That already covered here. I can go to I to K via one hop and then I'm checking K to J I can go or not. It means I to J via two hop like this, right? Okay. Any other doubt? Anyone?
No, sir.
Okay. Great. So we have all the 11 week in the syllabus. So please go through that. And we have still remaining 2 weeks for end term and we have enough time. Week 11 is already covered. So next week we will have revision sessions. Okay. So revision
Sir, may I know how many revision sessions would be there?
week 1 to 6 and then 6 to 11, 2 sessions.
Like in 2 weeks, only 2 sessions are there, sir.
No, next week, next week.
Okay.
This week, Friday and Saturday, like you can tell us if you want any other topic to discuss, any topic you are facing issue, we can discuss that. Okay.
Okay,
This
sir.
11th week 11 lecture, she taught us actually little bit rushing towards this practice assignment. I was expecting today you would be solving practice of week 11.
Yeah. So I planned that
Summarization
only,
of
but
DFS.
someone said already discussed. That's why.
But that's what if you would have been explained, that would be great.
Okay. Do you have any
Yes,
specific
sir. Yes, sir. For
doubt
next
here?
in next class.
Everybody's
Maybe.
expectation you to solve this practice so that we have a clarity. So next session, please try to come, sir, so that we'll be having
Yeah. In next session,
good
we'll
idea.
discuss this one. Okay.
Yeah, please
And
include the
DFS, BFS
summarization.
clear?
Yeah.
Yes, sir.
No.
Okay. So next session we'll discuss this practice assignment because important topic is there, that is basically recursion part, right? So
Yes,
if
that
you
is what a big confusion.
Yeah.
Yeah.
Please summarize the DFS and BFS also, please.
Yeah, so maybe next session we'll discuss this. Okay, week 11 again.
Next
Sir,
session, will
next
you come?
session would be
Because
on which day?
yeah, that's what I'm also asking. Next
Uh,
session
According
would
to
be on
calendar.
Friday.
Friday and Saturday.
Everyone want you to solve, sir, actually.
Okay.
What
So
sorts?
Saturday we can discuss. Okay.
Friday and Saturday.
Friday we have session. Mandipa will take that session. Saturday we can discuss this session. Okay. Week 11.
Saturday,
So
we are expecting you to come. Okay.
yes.
Thank you,
So
sir.
Thanks for the session.
any agenda for Friday session? You want any topic to discuss? Will inform
Yeah, you
me.
can brief DFS and BFS concept.
Okay.
Yeah,
DFS,
that.
BFS. Okay. Saturday we'll discuss this week 11 again. Yeah.
Actually, uh, uh, like the coding starts from week 5 to 5 only, right? So like most of the syllabus, like complication syllabus starts from there, right? We want like more biased on week 5 to 11 rather than 1 to 4.
Sir. Hello.
Yes.
Can you please, sir, summarize the DF and DFS?
Yeah, it will take time. So maybe next session we can discuss. So okay. You have any specific doubt in DFS, BFS? Okay, next session we will discuss, don't worry, along with the pseudocode, okay? So recursion is a very important topic. If you see previous year end term, 2 questions are there, okay, from recursion topic, 1 or 2 questions. So try to focus on that recursion part.
Sir, may I know the paper is made by a professor or computer-based paper, sir? Like the AI will be generating the question.
No, professor.
Okay.
Sir, please share that PDF on which you have written some notes.
This is already slides only available in the slide section. Same I have
Yeah,
done.
slides are available, but you have done some written work on initial PDF now. Yeah,
Okay, this
this
one.
one.
Yeah, I
Yeah.
can share, but I don't know how it's useful it will be. My handwriting is very bad. Yeah, I will add this in the supplementary content folder. Okay.
Okay. Yeah, thank you.
Sir,
Because
can you
it's easy to revise us. No? You have written something, so we can remind and we can do revision easily.
Okay. I will put it.
Sir, can you explain week 9 graded assignment question second?
Graded assignment, right?
This kind of, I would like to ask, this kind of hop and two hops questions and distance, can we expect in end term?
Yes. Syllabus is there, week 1, 2.
Okay, so that is same train data set they will be giving or some other?
No, like whatever the question we have in week 11 in practice or in GA, similar type of question.
Okay.
And 1 hop, 2 hop, also we can give the graph, and based on that you need to decide how many nodes we are traversing through, right?
Yeah.
Which question? Sorry, question
Sir,
number?
question number second. Sir, you just tell me how the matrix is working. Question number third.
No, your doubt. Okay, question number third, right?
Yes, sir.
So this is the question.
Yes, sir.
Graded answered. Yeah. So it is similar to what we have discussed, I guess. Yeah. So for each row in table, easily 2 authors contribution from the both no different one. Yeah. So there is a pool of n authors, each author being assigned unique index value from 0 to n. Right? Let's say we have 5 different author and we have 0, 1, 2, 3 assigned to that. So here we have author and we have index value. Author is what? Let me write it down here. Author. So let's say A, B, X, Y, M, N, O, P, Q, R. So we have 5 like this, starting from 0, 1, 2, 3, 4, 5. And yeah, n equals to 5 we have considered. So serial number 0123. So this is 0123, and index value also we can consider same here, right? Ending 0, yeah, 0 and n minus 1. So table is represented by dictionary name book and then key serial number values and a corresponding list of authors. That books has already been computed. So book 0 is basically 4, 0. Author 1, author 2. So we are going to convert this table into a dictionary. In that, the key will be a serial number here and the corresponding value will be what? The list of authors, author 1 and author 2, like this. Okay. The graph G is generated here. From this table, each node corresponds to an author. There is an H between I and J if and only if there is collaborated on a book. So collaborated means author 1, author 2 are together for that serial number. So given pair of authors IJ with I is not equal to J, what does the collab indicate represent at the end of execution? Assume that the value of author N is given to you. Okay, what is your doubt here?
Sir, here how the dictionary books is made.
Books, okay. So here if I say this is the author 0, 1, 2, 3, 4. So inside the books dictionary, let's say I have this one. So author 40, 0, 1, 2, 3, again 4, 2. So we have these 4 rows and sequence number is 0, 1, 2, 3, like this. So in the dictionary, serial number as a key. So for 0th serial number, we have a list. Author is what? 4, 0. Then we have one more serial number 1. Author is what? 0, 1. Two authors are there. For next sequence number, we have 2. And the author is what? 2, 3. And then we have third serial number. The author is what? 4, 2. So we have 4, 2 means what? Index 4. So QR and MN has written this book. 2 means 2, 3 means what? MN and OP has written this particular book. So this is a dictionary for books here. Okay. Now once you got this particular books, what we are trying to do here, and we already know that is 5 authors are there, 0, 1, 2, 3, 4. Collab create matrix. So empty matrix of 5 by 5 for each I keys of book. Keys of book will be what? 0, 1, 2, 3, like this. So number of rows can say starting from 0. So we have 4 rows we have considered. Author 1 will be what? First of book of I. So for this particular thing, iteration I equals to 0. First is what? Tell me. First of book of I. Yeah. So first element of this list 4. Author 2. Second element of list 0. Now
0.
if this author 1 and 2 collab of 4 authors is equals to what? 4, 0 plus 1. Right. So initially it is all 0. So that will be 1. Again 2, 1. So 0 and 4. Again this will be 0 and 4 plus 1 will be equals to 1. So what we are trying to do inside this collab matrix here. So here if author has written the book together, then it will be represented by 1. Okay. So number of books written by the author, that will be considered here in the collab dictionary, right? So given a pair of authors IJ, what does the value of IJ represent? So it represent number of books. Is it the correct answer? What is the answer for this question?
Sir, B.
Number of books in which author I have collaborated. Yes, number of books in which the author I and J have collaborated. Yeah. Okay. So here we are first finding out, taking two author 1, author 2, and then in the collab dictionary, what we are doing in the collab matrix, what we are doing, we are keeping a track of author 1, author 2, and number of books they have published. So plus 1 again. Again, if you have one more such book, again, so that will be 1 and 1, that will be 2. So number of books published by the authors I and J together. Okay. So this is what the
Yes, sir.
pseudocode is doing. So for this, I will suggest you to watch a practice assignment Sochu that I have taken. I think similar example is there, but that is on trained data set. Okay. So if you watch that, so you can understand this entire thing. Okay.
Okay, sir. Thanks, sir.
Okay. So that's it from my side. Thank you. Thank you everyone for joining.
Thank you, sir. Good night.
Thank you, sir. Good night.
Thank you, sir.